Hello friends, today we will see flashing circuit. Someone is called it as a strobe circuit like an aeroplane. So let's see is it actually working or not, because we are not giving any kind of base voltage over here. So how the transistor will work on this case. So let's see. This 12 volt VCC will allow LED to blink, you can see here. Now this is how the circuit is looking like. Now the thing is our gate is open, so how we are going to like a collector current will transfer and how this LED will work, because we know like transistor is working as a switch, it will turn on and off. But here in this case there are some scenarios that we are going to consider. So first of all, if the base current or there is a no voltage across the base, that time we have base emitter junction, like this base emitter junction. If there is a no voltage across base and emitter, that time also there is a very little current flowing through the collector, like IC is flowing, but that is very little. In some cases, if the noises get added, that time that current will flow and that current will allow this LED to turn on. Now the second point we can consider is this capacitor, which is playing crucial role in this case. If we apply the 3.3K and 100 microfarads of capacitor, if we are going to use, then in this case what happened, we get the tau, that means the time constant we are getting is nothing but the R into C. So what is R over here? R is 3.3K multiply by we have 100 microfarad. That means what exactly we are getting is the value 0.33 millisecond. So for this second our transistor our LED will turn on and off. So this time constant we are getting, and this is like if 12 voltage we have applied, that is allow this capacitor to charge, because this transistor is working as an open circuit. So this will allow the capacitor to charge, and when the capacitor is charging, that time there is a this voltage we are not having, so LED is in the off state. But when there is a discharging path to the capacitor we are giving, then this capacitor will flows like this and will go give the path to this LED through this resistor, and we are getting the LED to turn on. So while discharging the capacitor, LED is turned on. At the time of charging, LED is turned off. And this is how the circuit is looking like, a flashing or strobing circuit we can say. Now the thing is, if we apply the VCC, and that VCC is equal to, if we apply VCC is equal to 5 volt, that time we are not getting any kind of voltage or LED flashing over here. You can see that in the video also, because the 5 volt is not sufficient to allow this IC current to increase, and this LED will not turn on, because LED require at least 1.7 volt or more than that according to data sheet to turn on, and this 5 volt will not allow to go, right? So this VCC should be greater than 10 volt to turn on this LED, and it will turn on and off. So the values you can play with is the resistor 3.3K and the capacitor. If you change these values, the tau will change and allow you to LED turn on and off at a different time.